Hello, and welcome to how to make a 3D environment scanner. There's already a few 3D scanner tutorials out there, but this one's a little bit different. First of all, while most scanners use a turntable to scan small objects, this one turns the camera and laser to scan around itself at 360 degrees. So this means that it can scan an environment such as a room or a cave or an outdoor scene. It can also be used to scan people, vehicles, or whatever you want really. The other reason it's a bit different is because the programming is written completely from scratch using only Arduino and processing. It doesn't use any pre-made 3D scanning program. This means you can tweak and alter it however you like to fit your scene, which makes it much more versatile. You can watch how to write the code in these videos, or you can head over to the Intructables version and download the code straight from there. And if you like, I'd really appreciate your vote in the full spectrum laser contest. This scanner can be used for things like game design for proper environment modelling, or you can just use it for taking 3D selfies. I'll go into more detail later on about how it actually works, but basically it's just a webcam looking at an outline profile of something illuminated by a linear laser which is spinning around on a stepper motor. This part will cover the build of the scanner, the second part will go over the Arduino code, the third part will show you how to filter the webcam feed in processing and turn it into useful coordinates, and the fourth and final part will show you how to take that filtered footage and turn it into a 3D point cloud. So to make the scanner, you'll need an external webcam. It doesn't have to be a fancy HD one, in fact standard definition is better in this case. You'll also need a linear laser, a stepper motor and pulley, or you can also use a servo or a DC motor with an encoder, as long as you can control its position. A small section of timing belt, about 10 cm should do it, an L-shaped bracket, a 9mm Terry tool clip, a 3 AA battery pack, a tripod, any kind of tripod will work fine, some chunks of wood, a few nuts and bolts, and a few zip ties to hold stuff together. And for the electrical side of things, you'll need an Arduino, an LCD screen, a stepper motor driver. I'm using the A4988, a 100 microfarad capacitor, a couple of potentiometers, a prototyping breadboard, a 12 volt power supply, and a bunch of wires. This next part isn't too difficult. All you really need to do is strap these three things together. Perfect! The exact dimensions don't matter that much at this stage, just make sure that you measure them accurately for later on. So for the main arm, take a length of flat batten. I'm using a length of 40 cm with a width of 3.5 cm and a thickness of about 1 cm. You then need to drill a bunch of holes in it for the webcam, stepper motor, battery pack and laser etc. You can find the measurements on the Instructables, but honestly it's not that important. So first of all, I'm using a few zip ties to secure the webcam to the far end of the arm. I've had to connect a couple together because I didn't have ones long enough. Next we can take the Terry tool clip, pop a bolt through it and stick it in the other end of the arm. This tightens as it's screwed in for holding the laser firmly. Make sure to angle the laser as straight forward as possible. Next, take a small length of wood and drill a couple holes in either end and pop through some long bolts to make a simple clamp. This will hold our battery pack for the laser. And tighten it, making sure there's still enough room to use the switch. I'm just twisting these wires together for the moment, but you might want to solder them to get a better connection. Next, we need to fit the stepper motor shaft into a hole in the centre of the arm. Make this as tight a fit as possible. This fits quite snugly, but because of the weight of the arm and the jittery movement of the stepper motor, we need to secure it more firmly. So for this I'll use the pulley with that bit of timing belt to hold onto the arm. Use the bracket with a small block of wood bolted onto it to fasten the timing belt. Here I'm just using a couple of holes and zip ties to fasten down the webcam cable. This is so it doesn't get pulled while it's being used. When you're doing this, make sure you leave enough slack so that it can still turn easily. Here I've made a basic clamp to hold the stepper motor steady on a tripod mount. And again, if you want more detail on this, you can go and check out the Intructables tutorial. It's just a couple blocks of wood with one screwed down to a batten and the other one free to slide along two long bolts. And the holes drilled on the underside so that the tripod can screw into it. This one that I've done is tight enough that it doesn't need a nut, it can just be threaded straight into the wood. And finally we can slot our stepper motor neatly into the clamp and tighten it all together. So that's us done for the mechanical part. Now we can take a look at the electrical stuff. You can fit this all into a small project box if you want. You'll need quite a bit of room though. I'm in the process of making one just now, and I found that a bigger Kerry tool clip works great for clipping it onto a tripod leg. So here's a schematic for the motor driver from the seller's website, and here's a list of the microstep resolutions. We'll be using a quarter step, so we need to connect pin MS2 to 5 volts. And here's a combined schematic of the whole electrical circuit. I'm using an I2C screen here, so it only uses 2 signal wires, and they're both connected to the SDA and SCL connections on the Arduino. The stepper driver's step and direction pins are connected to digital pins 9 and 10, and the 2 potentiometers are connected to analog pins 0 and 1. So that's it for the first part. In part 2 I'll show you how to program the Arduino so it can send motor angles to the processing sketch. And if you enjoyed this, then please leave a like, and if you want, go and check out the Intructables version, the link's in the description.